Today we're going to talk about inverse functions. Make sure to have your notebooks out and ready. The word inverse in our case kind of means opposite. There's a few other meanings to it, but for today we're going to say it means opposite. So when we use inverse functions, we're talking about opposite functions. So consider a function with the following inputs and corresponding outputs. Notice that the inputs and outputs of the original function and the inverse are reversed. My x values over here in my original function now become the y values in my inverse, and the y values of my original function are the x values of my inverse. So that's one way where we can say these are opposite functions. In function notation, our original function is f of x, like we've been using for a long time now. Inverse function looks like this. We say f to the negative 1 power of x. That means the inverse of f of x. It's extremely important to use function notation with inverses, so make sure this gets in your notes so you can remember it for later. To find an equation's inverse, first of all, we switch the x and y variables. Then we solve or rearrange for y. In other words, we're isolating y and getting everything else to the other side. And then we replace the new y with the inverse function of x. So let's take a look at what that looks like. We're going to start with an original function of f of x equals 2x plus 3. I'm going to change f of x back to y. I'm going to then change the x and the y placement, right? My x becomes y, my y becomes x. Then we're going to isolate y, right? I'm going to subtract 3 to the other side to start to get y by itself. Then I have 2y equals x minus 3. And then how do I get rid of the 2 in front of the y? I'm going to divide everything by 2. Don't forget to do both divisions though, right? X gets divided by 2, but so does negative 3. Make sure you do both divisions so that I get y equals x over 2 minus 3 halves. Then I'm going to change the y into the inverse function notation, and there's my inverse function. The domain of my original function will be the range of my inverse, and the range of my original function will now be the domain of my inverse. We'll take a look at that in just a minute. Let's try that one more time. Let's find the inverse of f of x equals 4x squared. Again, we change f of x back into y. We're going to switch the x and the y placement. Now we're going to start to isolate y, or solve for y. I'm going to divide both sides by 4 first of all to get that out of my way. Now, here comes the tricky part. How do I get rid of a squared? What's the opposite of squaring? That would be taking a square root. So to get rid of something that's squared, I'm going to square root both sides. The square root of y squared will just be y, and the other side I can't really do anything with, so I'm going to leave it as the square root of x over 4. When I change y back into the inverse function notation, that's my inverse function. So the inverse of f of x equals 4x squared is f to the negative 1 of x, or the inverse of f of x is the square root of x over 4. Make sure that these examples get written down into your notebooks. Pause the video if you need to rewind and go back. Just a couple of reminders. Domain stands for all the x values that can be used in a function. So if there's an x value that you can't use, you kind of have to take a note of that and write a domain that fits the situation. Range stands for all the y values that can be outputs of a function. So all the y values you can get when you put in all of your x values. X values are called the independent values or independent variable. And the y values are called dependent. Y is your dependent variable. The y values you get are dependent on what x values you use. So let's hurry and look at domain and range for just 1 second with our example that we did just a second ago. First of all, let's look at 4x squared. What x values can we put in for x in this case? Is there a limit? No, not really. We can put in pretty much any number for x, right? So we say our domain is all real numbers. What values will you get out, right? What y values will you get? When I put in any of those x values, what will my y values look like? Take into consideration for just a second that since x is squared, that's always going to be a positive number. When I multiply it by a positive 4, it's still going to be positive. So our range is going to be all those positive numbers, and I can write that as y is greater than or equal to 0. This means all those positive numbers. Now let's look at the inverse function. What x values can I put in for x? Look at how we have a square root here. Can we take the square root of a negative number? Well, we found out a couple units ago that we could. However, we don't want to take the square root of a negative number in this case and get into imaginary numbers. So x over 4 needs to be positive in order for us to take our square root. In order for that to happen, x has to be positive. If x were negative, I'd be getting into imaginary numbers again. So I'm going to say that my domain is x is greater than or equal to 0. I don't want to be putting any negative values in for x. What values will I get back out? If I put some of those positive values in for x and divide that number by 4 and take the square root of it, what am I going to get out in return? I want you to think of something really quick before you answer that though. If I take the square root of 4, for instance, I can have that be a positive 2, or I can have that be a negative 2. So when I take the square root of a number, I can get positive or negative answers. So in that case, knowing that this square root could give me a positive answer or a negative answer, what can I say my y values will be? It's pretty much going to be anything, right? There's not really a limit on the numbers I can get as outputs of this equation. So I'm going to say my range is all real numbers. Take note really quickly that the domain of one of these functions is the range of the other, all real numbers, all real numbers. And the range of the first original function, y is greater than or equal to 0, is similar to the domain of the second one of our inverse function, greater than 0, greater than 0. That will always happen with inverse functions. We'll do some more examples in class on domain and range. Make sure you have the examples written down, write down any questions that you want to ask in class, and have a great day.